So, last talk of the day, and we're in for a bit of a treat, because I am talking about SwiftUI, everyone's favourite, and I am also talking about SVG. And this is a love story. So, as all good love stories do have, there are two people involved. In this case, there is a boy called SwiftUI and a boy called SVG. So it is a very nice love story, and please join with me in hearing all about it. So the story we are going to be telling has a couple of parts. We're going to meet the parents of the couple, that is everything that has gone before. We are going to look at who the couple are. We're going to look at how the couple met and also their relationship. So, first things first, let's look at the parents. Let's look at the history. Let's look at what our landscape is so far. First off, we have raster images. Now, raster images are everyone's favourite bitmaps. That is, in order to display an image, we have something which is just a series of bits that represent, is this green, is this red, is this blue, what colour is this, stuff like that. It is how most things like JPEGs, GIFs, PNGs, all of that are made up. We also have what's called a vector image. So vector images are these very nice things where instead of saying this particular pixel has this colour, this next one has that colour, what we are doing is we are saying, hey, draw a rectangle here and that rectangle is red. Draw a line here from point A to point B and that line can be blue. So what we have then is a way of just being a bit more descriptive of how an image should be built. Now, with any app these days, we are going to have to deal with large image sizes. So, large image sizes, we want to have stuff that is very beautiful in our apps. We want to have images that look really nice because that's what adds detail and depth to our apps. We also have to deal with different screen sizes. So now that, like, even for many, many years, we've had two different iPhone sizes, we've had iPad sizes, we've had all of these different device sizes that we need to deal with. And now every iOS developer is also a macOS developer. Yay! Join Team macOS. We're here for the fun. So with the different sizes, particularly if you're using something like Catalyst, you then have a window which is resizable. And that is going to cause issues with your images. So what we have there is just the parents, the background of what is going on. Now, let's meet the couple. We have the new boy on the block being SwiftUI. So SwiftUI came out this year in June at WWDC, and there are now apps out there in the wild using SwiftUI, and it is amazing. So who SwiftUI is? SwiftUI is a declarative UI. So how this works is you describe in detail what your UI is going to look like, and then the system will run and do all of the interactions and display the UI. Another thing that SwiftUI is it is immutable, meaning if you have a view and then you say, move the view from point A to point B, the view at point B is a different view from the view at point A. Couple of nice things to keep in mind about SwiftUI. The next one we have is the older boy being SVG. Been around for a while, been around since 1999, and has gone through a few different iterations. the version of the version of SVG we are working with in most cases is version 1.1. If you enjoy looking at the W3C standards and reading in detail about all of that, there is a version 2 which is in draft at the moment and has some advancements and extensions, but we're not dealing with those. We're really just looking at SVG as a very small subset of what it can do. Now, SVG is vector graphics, meaning it is declarative itself. It will describe everything that is being done, everything that is being drawn. How it does that is it makes use of XML, everyone's favourite. Now, XML is far better than JSON because XML has types and definition. JSON, even if it's JSON being sent to and from a GraphQL server, doesn't have types. Okay, how they met. So these two boys, they have a lot in common, they go well together, they get along really, really well. So in order to get along better, they both have a passion for understanding each other, and they have a mutual cooperation about everything. Now, in every good love story, there is competition. So there are a set of other suitors involved, as in other people that want to get in on this love story. Now, these are just different ways of drawing SVG. You have something like SVG, which is used in IconJar, and this is a really, really good Objective-C library, and it uses manual reference counting. So everything that makes Tim very happy. Now, another way of dealing with SVGs and vectors is you can just use PDF files. Like, they can be vector graphics, but they're a bit ugly to deal with in an iOS app for icons and general images. You can also just use WebKit. You can go, hey, here's a web view that we're putting in there, and we're just going to throw the SVG data into that. That has some benefits in that WebKit itself renders SVGs really well, it is well defined, and it is quite extensive in everything it handles. But we're not talking about all of that. This is the story between SVG and SwiftUI. So, we have talked about the parents, we have talked about the couple, who they are and how they met. Now let's look at their relationship. That is, how do the two come together and how do they make sense of everything going on? So, one of the big things is that the two help each other get to know each other. So let's get to know SVG a lot better. Now, SVG, in order to understand it, we need to understand his type. So SVG is an XML file. It is defined using that. Now, with XML, everything is very much an element. You have a very hierarchical tree structure in there. These XML, I'm just going to call them nodes, I'll explain that in a little bit, has attributes, and then there's also some more complex things in order to do the really fancy drawing called path commands. So let's take a look. This is an SVG file. It's quite nice, it's got some definition in there, it's saying what standard version it's at, and then we've got things that are well named and well defined. We've even got comments and documentation in there. Everything JSON doesn't have. But yeah. So what we have here is it's going about drawing a few rectangles, a single rectangle and then two ellipses. One ellipse is contained in a group, and that group has a transform on it that moves it from point A to point B. The other ellipse, again, has a transform, this time moving it to a different point and doing a rotation. Cool, fairly easy to understand, all of it is there. So how do we take that particular XML and look at defining it in code? So the easiest way is to use an XML parser, and Apple provides that for you. So this is one of the functions from the delegate callback that you get. Most of the code I'll show you today is all snippets of the final product, which is available on GitHub. The link to that will be at the end. So some of this might look a little bit out of context, but I'll explain the important parts. What we have here is it's just encountering an element as it comes along. It is looking at what type it is. So we're using an enum here, some nice short Swift syntax. We are then creating the node itself. We're going, is this something that is apparent or not? This is in order to handle the hierarchical tree structure. And we are also looking at whether this is in fact the root of the tree, which is quite beneficial. So taking that from our XML parser, we then look at our node. This is at the moment 500 lines in a class, a little bit on the nose, but it does the job. So the reason why I went for a single class here is that it will allow the interpretation on the SwiftUI side to be a bit nicer and to handle the distinctions and the differences quite well. Within that node class, we are defining stuff like attributes. And these are all of the attributes that can possibly exist on any node. And there are some that are available on, say, a rect, which aren't available on an ellipse, just where things start to make a bit of sense. Cool. Okay. Got some comments there as well about what the actual name is. So fill rule obviously changed it from a dash separator to being camel case and a few other nice things in there. And some of them, like the path commands, is expressed as the attribute D, which doesn't really make much sense. So we've just given it a nicer name because in our code we want the code to be very understandable. We then look at all of these path commands. These are, so with the path, the idea is it expresses all of the different operations that happen, and this is how we translate that into something we understand a bit more. So here we are with the enum definition of all of the operations. You've got, say, move to and move to relative. All of this will start to become a bit clearer down the track. This is pretty cool. Then let's now look at, say, you're interpreting a path and you come across a move command. What does this move command actually do? So what we have here is a series of commands with a capital M and a lowercase m. There is also an H in there, which is for drawing a horizontal line, but that's not the focus just yet. So here we have, starting off, a capital M, which is saying move to the coordinates 10, 10, and draw a line. We then have a lowercase m as the next command, and this is saying adjust the previous point to the new point by 0 on the x and 10 on the y, and draw another line. So this is the distinction between an absolute command and a relative command, where your absolute command is, hey, here we have the value, go to this absolute point, and a relative command is apply this difference to the current known point. Cool, so that's moving. Now we have line, horizontal line, and vertical line. What we have here is, again, the absolute and the relative versions of it. And we are drawing two lines, which all is pretty good. The first one on the left is the absolute, and then we have the relative on the right, and they produce the same result. Another path command is Bezier curves. So here we have stuff like a cubic Bezier curve, a smooth cubic Bezier curve. We have a quad Bezier curve and a smooth quad Bezier curve, all of which have some well-defined behaviour, and in XML it will look like this, producing the output on the right. Again, absolute and relative versions depending on the case of the command. We then have the arc. So this is drawing an arc, and it's a very complex shape. So what we have here is a series of commands which are positions on the X and Y, you've got angles in there, and then you've got two values being 1 or 0, being Boolean, which indicates stuff like the direction, is it clockwise or counterclockwise, and then we have coordinates at the end. So this starts to get very, very complex very quickly. Again, absolute and relative versions. We also have path closing commands, which is a way of saying, hey, you've done this path, now just draw a straight line from your current point back to your original point. Cool, awesome. That's the definitions, and now let's look at the fun involved in understanding that and bringing it into a world of SwiftUI. So what we have to do is the way in which the path commands are defined and laid out can be very, very complex. So you can have, say, a command of M followed by two values that can be either comma or space separated, and then you could actually have an infinite number of similar pairs after that as well. So we need to take a bit of care in our handling of it so that we know how to appropriately draw everything. And this is why even the differences between the web browsers don't always get it right. You'll see things slightly weird, but that's all good, and we've got standards bodies and known amounts of test data to actually show how well something conforms to the standard. What we're doing here is we're just getting a scanner, NS scanner if you're used to the older name, and we're looking at the particular values and commands in there. What we're doing is we're just scanning that to the character representing the command and going, hey, what command is this? Now, for things such as Z, both variants which relate to closing a path, they can actually have no space between it and the next command, which causes a bit of grief, and we're just dealing with it by going, hey, is this actually 2 characters long? If so, drop the first and move on. The syntax here is very much a while let, if let, guard let, but we're using var to get a mutable copy. And then after that, we're grabbing the rest of the particular command up until the next command character and storing it. In order to understand a command, so we've got something like M1010, we need to, again, pass all of that. So what we're doing here is, in order to determine the correct number of values, we are removing any commas and putting spaces in there. This way it just gets it to a known variant rather than going each time, is it a comma or not? So yeah, I have no idea how well this handles with localization, but if you're putting commas into a defined XML, yeah, like to show, say, 1,000 or 10,000 or something like that with a comma in there, I wouldn't like you. So we're just, after doing all of that splitting, we're getting all of the numbers and we're creating it as a CG float. There is a bit of debate around, should it be CG float, should it be double? I would much rather double, but a lot of manipulation around paths and actual UI components is CG float, so that's what I've chosen for here. Once we've grabbed the numbers, we then look at the action. So the action is that character representing the command, and we do some looping over that in order to generate our enum types and so on and so forth. Cool. That is handling all of the XML in a brief overview. Next one is we get to see how SwiftUI helps us understand everything about SVG. So this is the fun stuff. This is what we're all here for, to know who the new boy is. So what are the basic building blocks that we're going to be using in SwiftUI? It is stuff like rectangle, circle, ellipse, and shape. All of these get put into views and away you go. So in order to draw a rectangle, this is what we would do. So the element or the node has stuff like corner radius, fill color, stroke width, offset, width, height. All of that's in the example code I've prepared. But here we're just focusing on the display and the rendering. What we're doing is we're creating two rounded rectangles. We default to a rounded rectangle because it gives us the corner radius straight off. If you provide a corner radius of 0, you end up with a rectangle. Hey, it's all good. We're then drawing the inside one with a fill color, a default fill color of nil or clear can be used if you want. And then we're doing the stroke after that, which is the border. So with the rectangle element as defined in SVG, it will tend to use X and Y as the attributes, which are for the top left position of it. So we are then taking that X and Y and using it for the offset and width and height as required. Cool, awesome. Circle, very much the same idea. We're doing a circle for the fill and then a circle for the border. We do have a difference here. That difference is circle as an element will not give you X and Y as attributes. It will use CX and CY, which is the center X and the center Y point. This is more appropriate for a circle. We then use position. What position does is it, instead of saying here's the top left, it will go here is where you place the center. It's all pretty good. Circles get defined by their radius, so we are using that value as the attribute. Default of 0, if for some reason you're providing a circle without a radius, well, you shouldn't draw it. Ellipse, again, a variant on circle, but this time you have two new attributes being radius x and radius y. Radius x is for the x radius, and then y for the y. Cool. That's some of the basic primitives and how simple and easy they are in SwiftUI. Next, we have to look at stuff like line, horizontal line, all of this stuff that makes use of a path. So this is where shape comes in. So shape, instead of view, has a function called path that you pass in a width, a rect for the frame, and it will then allow you to do basic drawing. So path is pretty much a CG path, just a nice Swifty name to it because it's SwiftUI. So what we are doing here is we're getting a start point and end point from our node, which is the x1, y1, x2, y2 from the attributes, and we are going move to the start point, draw a line to the end point, and return the path. Now, here is a difference with path and CG path. In CG path, you can directly apply stroke color, fill color, all of that. In SwiftUI, you need to actually do those commands on shape rather than path. So the way I solve that is having a wrapper view for the line. That line makes use of path, which is a type, and is used like this. Very straightforward. So taking all of those building blocks and putting it together, our top level SVG view ends up looking something like this. What we have here is a little bit of trickery in SwiftUI as well, where we're making use of a geometry reader. A geometry reader is there so we can take the dimensions of our SVG, which could be something like 1200 by 400, and convert it down to the actual space of the SwiftUI view. So here we have our outer geometry reader. We're getting the ratio, so we need to create that as a variable, which means we then need to use the return statement. Because SwiftUI has some differences around drawing the types of views, we do need to wrap this whole command in any view in order to just gloss over all of the different types and make it all behave very nicely. Now, as mentioned before, well, glossed over a little bit, SVG is a tree-like structure, meaning you have a node at the top and then you have several branches as you go down. All of these people doing tree structures in interviews, there is actually some use of a tree structure, but not that often. You don't need to do binary trees, balanced trees, all of that. It's not worth it. So the previous slide had a draw command on it. This is part of that draw command where we are doing a Z stack because we want arbitrary placement. And then we are looking at all of the children in an element. We've got a group. Now, one of the things about SwiftUI is if it gets fairly complex, it will error and end up going, hey, this thing is too complex to solve in reasonable time. What I've done here is created a whole heap of helper functions which return optional views, and that just gets rid of all of that. So for each element, we'd go, is this a rect, a circle, a group, an ellipse, a line, a polyline, a path, and render it appropriately. Now, we then apply transforms, stuff like translate and rotate, all of that get applied at the end. Okay, more complex stuff, which again is the path commands. This is all pretty cool. So for the path commands, they can be really, really complex, really long, and we have them here. For the path, we created at the start, and then we just loop over all of the path commands which are applying different modifiers like movement, line, arc, Bezier curve, stuff like that, and returning the path at the end. Let's look at how these are done for some of the different path commands. Move to. Very simple, we're just going path.move to point. Relative version then means we need to get the current point and apply differences there. Current point is optional, so if we don't know the current point, we just assume 0. And away we go. Line. Here we've got adding a line and to a point, which is fairly straightforward, and then adding a line based on relative positioning. Horizontal versions, much the same, where we're going, hey, we don't have a starting vertical, but we know the new horizontal, so we get the vertical and then apply the horizontal. Relative as well. Counterpart in vertical, where we have we know how much along the vertical we need to move, so we just rely on the current points horizontal. Bezier curves, yay, everyone's favourite. This is where math starts to get a bit more intense. So we need this thing called control points. In a very simplified version, this is what we are dealing with for a cubic Bezier curve, because the path command gives us both control points. Winner. Cool. That is how SwiftUI then starts helping us understand everything about SVG. So, I mentioned before that all of this will be available, and the two plan to elope. They've got a great relationship going, and they want to know more about each other. It is all up on GitHub. I will make this link available later, tweet, Slack, everything like that. As always, with any open source project, feel free to provide an issue if you have questions, or provide some enhancements via a pull request. Now, all of this wouldn't be possible without some really, really good documentation out there. Mozilla's documentation about SVG is definitely the best, and that is available there. Again, slides will be shared if you don't take a photo. W3C, so the World Wide Web Consortium, is the official specification. This is for version 1.1. And Apple's documentation on SwiftUI, again, very helpful. Last of all, thank you, everyone. You're amazing, you're awesome, and enjoy the rest of the conference.
Yes, there are questions, of course, because you made some controversial statement.
Okay. Why are PDF images ugly to deal with? That wasn't you? Why are PDF images? So if you're using PDF images as far as putting them in the asset catalog, what I understand happens is they actually get rendered at a few different sizes, and that's how they end up working in your app. So you ultimately end up with a 1x, 2x, or 3x. If you're doing a different version and not using the asset catalog and just sort of using a PDF library to draw it in, then you will get some of the benefits if they in fact a vector-based image. It's just a bit more work, stuff like that. Does SVG have better performance than PDF? That's all based on how well your rendering side and your parsing side are. If you've got a well-behaved PDF library, there would have been a lot of time and effort put into that. If you've got a well-behaved SVG library, then again you'll get a lot. They'll pay attention to stuff like background rendering and the performance of parsing all of the different things. Are both SwiftUI and SVG boys? Yes. Why isn't attributes a struct instead? None of the attributes change. So my preference for how do I handle in code about what I want to do with all of the different attributes makes a bit more sense as an enum. Personal preference. Do you have a library published for this? Yep, they eloped to GitHub.
All right, thank you, Matt.